Good morning, everyone. Welcome, welcome. We've got quite a full schedule ahead of us, so I thought we might get the day started. For those of you who don't know me, my name's Annie McNeil from the University of Adelaide. I'm the branch president of the Australian Soil Science Society for South Australia, and I suppose this workshop is the brainchild, if you like, of Teresa Fowles, who's the chairperson of ASPAC, and myself. We got together over coffee one day and thought we'd get a small group of people together to talk about this issue, and we're really amazed to see how many people were interested in it. Obviously, it's clearly a hot topic. So I hope you enjoy the day. We've tried to bring in a range of speakers across topics from measurement of carbon through to how it's applied in the policy and in the agricultural and natural resource situations. Hopefully you'll find some information that's useful. It will stimulate you to discuss things. It's very important, I think, to ask questions and to make full use of the interaction that you have with people. So I just encourage you to enjoy yourself and hope you have a good time. A couple of bits of housekeeping. The toilets are, as many of you might have found them already, are very close to where the catering's going on, just next to the hatch, which is down in the other building. In the other building, I think that's one of the main pieces of housekeeping. There's water at the back if anybody gets very thirsty. There's some cold water, and that's probably it. Is it, Matt? I don't think there's anything else. Yes, please. Could you either put your phones on silent or off? That would be appreciated. And that's about it. So, and it looks as though Neville's not in the room, is he? Neville Crossman, no. Neville was going to chair the first session, so I will do that. And we'll start by the first person who's stayed at my house last night, so it's quite well known to me. Bill Slattery from DCC, the Department of Climate Change and Energy. Bill is a senior research scientist working on greenhouse and agriculture issues with the DCC, and he's worked in the agricultural sector for a very long time. Many of you may already know him. He moved to Canberra in 2002 from the Rutherglen Research Institute, where he'd spent many, many years. He has a very good background in soil science and the measurement of greenhouse gases from agricultural soils, and previous to that he was working a lot on conservation farming and acid soil research. Although he's spent most of his time in the grains industry, he has been active across the sectors. So I invite Bill to give the opening presentation.
Great. I'll just pour a little bit of water. Great. Well, thanks very much for the invite, Annie, to this workshop, and I'm very pleased to be here today. What I want to do in my presentation is give you a bit of an overview of national inventory. So I'll sort of deviate a little bit away from the carbon story, but I think you'll enjoy the context, I hope. Then link between that inventory and the CFI, the Carbon Farming Initiative, which most of you have heard about, and it is really pertinent to our discussion today on carbon and carbon protocols. And we'll look at the measuring versus modelling aspects of those two systems. In terms of our international reporting, I'm not sure how many of you understand what goes on in that particular area, but we report to two international reporting formats. One's Kyoto, and the other's the United Nations Framework Convention on Climate Change, UNFCCC. So for those two reports, we report different things, and there are particular categories there: enteric fermentation, ag soils, fertiliser, nitrogen, manure, urine, rice, savanna burning, crop residue burning. They're particular categories that are been set by the international bodies, and we report to those. And only the non-CO2 gases for Kyoto, and the non-CO2 and CO2 gases for UNFCCC. So all of our carbon reports go in UNFCCC reporting, because Australia didn't elect soils under Kyoto. So that's a bit of context. And in terms of our accounting methods, some of you may have heard about Tier 1, Tier 2, Tier 3 accounting methods. Tier 1 is where we use the international default factors for emission factors, and that would be, say, 1.25% of nitrogen applied as nitrogen fertiliser is lost as nitrous oxide. That's an international default. A Tier 2 is where we've done some in-country research and develop a new emission factor. So for the grains industry in Australia, 0.3% of our nitrogen is lost as nitrous oxide from applied N. And Tier 3 is where we actually move away from emission factors and start to use models. So in the context of this discussion, our carbon modelling is most definitely what we use for that Tier 3 level for our UNFCCC reporting. Okay, so I think in terms of how we get that information, for Tier 1 and Tier 2 accounting, we use ABARES data. So the reported statistical information that we get nationally is what we use to populate, and we get some information from CSIRO to deliver yields into that database. But certainly activities related to the different agriculture sectors comes from ABARES. And fertiliser use, etc. So it's not perfect, but it is the most complete, and it is the most complete that we are able to obtain on an annual basis, and that's the critical thing for us. So you might think of some landscape and land use analysis that's been done, very good data for a particular year, but unless it's done on an annual basis, we can't use that information. So for Tier 3 accounting, we use our full carbon accounting model, full CAM, to look at those changes in carbon stocks nationally. And that requires spatial attribution of data. So clay percentage, we have a soil clay percentage layer, that's the ASRIS layer, and we develop an initial soil carbon layer, which I'll talk about shortly. We have crop information, climate data that sits on top of all this, and all that spatial data helps us to apply a Ross-C carbon model at a pixel by pixel basis across the nation. Not perfect, but it's not a bad effort. In terms of the emission factors, every country has a requirement to improve their emission factor status. So the default factors can be applied for developing countries. Developed countries are required to use in-country research activities to support the development of new emission factors, or indeed move towards Tier 3 accounting. Australia is the only country that really uses the Tier 3 accounting process for its reports. Some countries use a quasi-Tier 2, Tier 3 approach, but we are certainly way ahead of the pack in that respect. And in some ways it can be a problem for us because we get hit with many more questions since we've now signed Kyoto during our review process. And how do we determine, if we're doing some research out in the paddock and we get some new data on, say, a canola crop, when do we decide that is new data that we can be uplifted into our inventory as a new emission factor? Is it after 4 individual experimental sites? Is it 2? Is it 1? And these are some of the issues that we struggle with from time to time. In terms of what we've actually decided with some new information is, so far all of the data coming out of emissions of nitrous oxide from low rainfall crops are very, very low, much, much lower than the IPCC default. So we've decided that we will select these new emission factors for grains grown in low rainfall areas. Now, what does that mean spatially, nationally? Low rainfall, where are they? Is it arbitrarily, is it less than 450 millimetres of annual average rainfall? Is it 550? So now we need some more research to identify where we're going to place those numbers nationally. And then, of course, when you move into a carbon farming initiative where we're paying for a reduction in emissions from this down to here, potentially, if a farmer could demonstrate through their improved nitrogen use efficiency that they've dropped from that emission down to here, we have to identify where that is spatially in Australia that they would be allowed to do that. So you can see that complexity of going from this, just getting a new emission factor based on research data, to implementing a carbon farming initiative paying on reduction in emissions through a carbon tax is actually not that easy. So in terms of our national inventory estimates, the data that comes from our Tier 1 and Tier 2 tables straight into calculations to estimate emissions from methane and nitrous oxide as CO2 equivalents. And our data from the carbon is pixelated across all of the nation to give us the carbon stock changes in CO2 equivalents as well nationally. So they get tabulated and reported, and that's what you see in the National Inventory Report if you ever looked at that publication coming out of our department. And so Tier 1 and 2 tier is just the tabular data which I mentioned, and the Tier 3 accounting takes account of the spatial layers, some tabulated data, because we need to identify what cropping practices or management practices are adopted within regions. The model uses the interim biogeographical regions of Australia, the IBRAs, which are quite large. So you can see in those large areas we've got a percentage of practices and crop types. So it's not perfect, but if we can disaggregate down to SLAs, that would be much better. We don't have the data to populate that just at the moment, although I think there is good data out there. So in terms of how the model was set up for carbon, we needed to identify where the start point would be. So for Kyoto, it's the average around 1990, 3-year average that sets the baseline, and it's the stock change beyond that to the next commitment period, which is from 2008 to 2012. So we're in our commitment period now where we get the accounts from each of those years and average that and compare that with 1990. And so how could we have started that process? We could have done a huge sampling analysis across Australia to determine what the soil carbon content was in 1990. Well, practically that wouldn't have been possible. It would have cost a fortune to do that. So what was decided was to identify what the soil carbon content was prior to agricultural intervention. And, it's not a perfect map of what the status of soils were in Australia, but soil carbon status was in Australia prior to agriculture. But it pulls together the prior vegetation cover, the climate, soil type, soil texture mainly, with some carbon estimates and measurements that were made on either native sites today, so new data, or old stored soils. So there's a lot of information that's gone into that. Queensland probably had the largest number of samples that we could use, which was about 2,500, and there was less data as we moved around the nation. And the big area in the middle of Australia, of course, there's just no data. So we primarily use this soil carbon map to do a run-in with Rothsea. So we start at a point which was a lot higher in soil carbon, and I admit that in some areas in Australia the carbon levels will be a lot higher than probably they ever would have been. But if we run our model long enough, over a 500-year period, we can come to an equilibrium which is fairly consistent with some of the measurements that we've taken out there in the field. And so we come into our new carbon stock level, and then we run our scenario, and that the time since clearing. So the date of clearing here is identified rather broadly through this work by Heathcote. It says, here, this is where land was cleared and when. So we can use that information, and then and if we use a sort of a realistic rotation, so we have different cropping practices since time of clearing in those regions, then we can run into a realistic value of soil carbon at total tonnes in the 30 centimetres. It's important to note that it's in the 30 centimetres, which we're testing and validating against the work that comes out of SCARP, Soil Carbon Research Program from DAF. So how do we link all this then across to the Carbon Farming Initiative? Some of the rules are that we need consistency between the Carbon Farming Initiative and the National Inventory. We can't really be offering credits to farmers that isn't recognised in the national inventory. We only have a certain amount of credits on a national basis, so we can't be trading outside of that total amount. But we also want to make sure that the scheme is a reliable scheme. It has value, so we need robust data collected through the Carbon Farming Initiative that potentially can backfill into the inventory. So if we get good data from the Carbon Farming Initiative, good soil carbon data that we have through very good sampling protocols, and we're confident that those values are robust, we can feed that information back into our pre-clearing soil carbon layer and get better data nationally. And we're at the moment trying to develop the FullCam tool. I don't know whether any of you have used FullCam as a tool, but it's very complex and difficult to use, as you will be aware if you've used it. We are in the process of developing a user-friendly tool for that tool. I'll just show this map because two of our key accounts within the CO2, the carbon stock change, are grassland remaining grassland and cropland remaining cropland. So it's clear that the bluey-green dots are the cropland areas, and the yellow is the grassland. Well, of course, we report on changes of stock in all of that grassland area, and we know our data's not very good for those areas. We need better data, and so I mean that's sort of a message I'm putting out there, that there is a paucity of information in those areas. We need better data. We are confident now that the changes in soil carbon stock are working well with the model across our croplands. We might have expected our croplands to have a lot. So this is the national picture, all of our croplands amalgamated into one diagram, and says that, you know, back in 1939 we had a much higher stock in soil carbon, and that has declined due to agricultural activity over that preceding years. So we're down at some sort of level down here. And in order to support the Carbon Farming Initiative, if we have our tool, our user-friendly carbon tool, our farmer can get out there and identify a paddock, run the model, and identify a change due to some scenario practice that they might adopt through the model. And you know, I've shown there we might actually validate and support that model with a measurement program, you know, at some interval, 5, 10 years. I guess that's something we haven't decided, and we need to identify through a sampling protocol how often we would get reliable information to support a model such as this. In terms of what we would expect to see then for the CFI, if proponents were out there and they were incorporating changes that we're expected to see a increase in soil carbon stocks, or indeed a decrease in soil carbon stocks, then we would expect to see on our line, our national line, a change due to those practices. And that is the intent, to link the two together. Now, we all know that there's a lot of noise in that, and you know, this line itself is a little bit noisy, and I would hope that we could actually mimic or demonstrate those changes, but it's certainly a big challenge. So our minimum requirements for tracking soil carbon for accounting purposes are collecting that representative sample to 30 centimetres is very important. We need an accurate estimate of bulk density, and as you'd be aware, bulk density is not an easy measure to take, and not often done. So, but we do need that bulk density. We're trying to put together a bulk density spatial layer. Man, is that fraught with some difficulty, I tell you. And we want an accurate measure of the organic carbon content of the soil sample. You know, none of these things are terribly simple in a sense. And I'm sure others will probably talk about this. Lynn's probably going to talk about this as well, but I'll just mention that briefly. You know, we know that the factors we need to consider when we're measuring soil carbon: sampling protocol, the temporal and spatial variability, and what measurements are we using in the laboratory. So just quickly, we know there's an error or variance associated with bulk density, maybe 10 tonnes of carbon. This is data that I've pulled out of various research papers. And it's the sampling process as well. Are we moving away that surface litter? If we don't, then you've got a difference there from one sample to the next that is critical in determining whether the soil carbon has moved up or down. Temporal variability. This is work here at the weight. It shows huge temporal variance between July and September, often when a lot of the soil sampling is done. So if we stick to a consistent time, maybe the temporal variability is not such an issue. This is one set of data, probably work that needs to be repeated. Spatial variability, how many samples do we take? How many are bulked together to achieve samples? How many samples do we then take off to the laboratory for measurement? There's huge coefficients of variance related to numbers of samples. Clearly we can't go into a paddock for a farmer and say, look, we're going to take all these samples and determine how many samples we need to identify a good robust sample. We've got to go out there and say to the farmer, here's a protocol, and if you use this protocol, you're going to give us the most useful information. So, these are some of the sampling protocols. That 5x5 strategy in here seems to be something that may be of use. But anyway, we can discuss these things later. When we've looked at a comparison between the modelled outputs of FullCam and some measured values, the comparison has been reasonably good. Oh, actually, this is not the one. This is a comparison between methods of analysis. We're going to the laboratory. What method do we use? And I guess much more we're heading towards Licofurnace and MIR, but I guess there are still proponents out there, or laboratories out there using Walkley and back. So we need to be aware of these things. So in respect to all of that, there are some considerations. When do we sample? How many samples do we take? How many samples are bulked? And how often do we take those samples to support what would be our requirements for carbon trading? Consider this. If we, and this is some real data, if I took a sample that was in 1991 and then another sample in 1996, and I would have got these two results, and I would have said, look, my carbon is declining at a rate of about 1 tonne per hectare per year. If I took the same sample in 1991 and another sample in 2000, I would have got a different story. And would have said my carbon's increasing at 0.1 tonnes per hectare per year. And you would have said, oh, okay, that's fair enough. If I'd modelled the data, there's the measured data. This is some data from New South Wales, Yin Chan's work. And so the modelling gives us the trend line, and our sampling can support that trend. And the question I ask is, what frequency are we taking, or do we need to take that sample to support that modelled outcome? And I think they're challenges that we as a group should be able to address. So in our measurement program then, pulling all those errors together, measure errors in spatial variability, bulk density, etc., our variance can be as low as 9 or as high as 22 tonnes of carbon per hectare. So that's quite a big variance. And so when we say, measurement program is far better than a model program, well, there's still errors associated with a measurement program. Unless we get those protocols absolutely spot on, then we're still going to have a lot of variance there. So when we compare some data from FullCam, so a modelled outcome versus some measured data, same lat longs, these are some of the comparisons that we get. So you get some real outliers and say, well, that's pretty crazy stuff, but in general terms, the data is not too bad. And if we were within that plus or minus 10 tonnes of carbon per hectare, I reckon we'd be doing pretty good. So as we know, I guess the key drivers are plant growth, our crop type, stocking rate. If we remove stock, maybe we get some vegetation thickening with above ground woody growth. But where do we move that stock to is the question from a CFI perspective. Are we just transferring the emissions to somewhere else? If we're cutting for hay, etc., where's that biomass actually going? Or indeed for biofuel. Rainfall's a key driver. Our clay content is also a key driver, and as we've seen from that pre-clearing soil carbon layer, the time since land clearing will determine how far down that curve you drive. So the National Accounting requires reliable estimates of plant growth across all the lands, and so we get that through some work with CSIRO and from ABARES. We need a reliable estimate of our initial soil carbon stock. That drives the whole process for carbon stock change. We want a reliable estimate of our management practices. How much no-till is being practiced in Australia? Is it somewhere up around 86% or higher? And for how long? And how much of an impact does that have anyway? Is it reducing our rate of decline? Has it actually increased soil carbon in some areas? Questions that probably haven't been answered to this point. And a reliable estimate of the land use change. When was land converted from forest to cropland, or in fact indeed back to forest land? Some of the satellite imagery that we get can give us insights into that. From the CFI perspective, in order to run a carbon trading scheme, they want robust and auditable data. So you tell me you had no-till here for the last 10 years. How do I know that? Trust me. So that's the sort of information that they will require. They need, and of course the outputs need to match our national accounts. This is very important for our national trading. And United Nations or the EU are pretty tough on Australia to demonstrate that this is actually the case. And we want, of course, our soil carbon management tool, this user-friendly tool, to meet the needs of this carbon farming initiative. And of course we want to ensure that genuine abatement has been achieved. So part of what I'd like to see out of today, if I may be so bold as to say, Annie, is that we think about the protocols, and I know Lynn's going to talk a bit about the SCARP work, and how we might use a protocol for the purposes of carbon trading, and there might be different reasons why we might use a different protocol for different outcomes. But for the purposes of carbon trading, we need to have a protocol that is robust and reliable, obviously that can be done easily in the paddock at different paddock scales, and can be used by farmers themselves to give us information that is good enough to feed back into the national accounts. So, thank you. I'll stay here.
Questions, which is fantastic.
Good. I'll stay here.
I did forget to say actually that this session is being streamed live on the web, so I hope there's nobody who doesn't mind being on camera if we're going to film the question and answer session.
Oh no.
So I'd like to call if there are any questions in the audience for Bill after that presentation.
John. Well.
One at the back there.
Oh.
Yeah, okay, sure.
You can hear you.
Question about, there's obviously lots of year-to-year variability, and FullCam kind of picks that up, and knows that table with lots of numbers. Some years where sinks of 60 million tons of CO2, other years sources. How would that match up with CFI crediting if there was a large uptake of soil carbon credits, say on the order of a couple million tons of credits being issued, and then we had a big drought year and FullCam shows that we just lost 60 million tons that year?
Yeah. It's a really good question, and it's one that we're struggling with at the moment. Clearly, we want our annual changes to be as minimal as possible. We can't control climate, of course, so our emissions. So if you think about our carbon stocks and that curve that I showed before with the cropping soils shows the soil carbon stock change. So that's relatively stable. The emissions, of course, will be will be higher or lower depending on wet years or dry years. If you think about a wet year, more biomass, more residue returned to the soil, more emissions. In a dry year, less. So yes, and when you multiply that across all of the lands, and particularly for grasslands, it's a real issue, because grasslands is over 440 million hectares, so little numbers become really big numbers. But the important thing for us is the carbon stock change. When we report on, and this is the crazy rules that are associated with this, for croplands we report on soil carbon only, but we report as an emission. So the stock change is a carbon change, but it's reported as CO2 equivalents. For grasslands, we report on below ground roots as well as carbon. So you can imagine, we don't have a lot of information about below ground roots in a lot of those, rangelands. So we will probably use, some generic values across those lands. But you're right, it's something that we have to be aware of, because we can't obviously be trading internationally if our baseline's doing all this. So we have to. So we think we've got a pretty good story now with our croplands, and we could probably demonstrate a change. Although, as you noted, there's still a bit of noise there, and even in that curve, dipping down like that, there are periods where I note that there's been a lot of no-till adopted, say for the last 10 years, and do we really see a huge change in that line? Probably not, So it's probably not sensitive enough to pick up those small changes, but we've still got to keep working on that. So good question, thanks, John.
Yeah, I'm a bit concerned about the assumption about the base and the deforestation. Just recently, Gamage has written a really extensive and enormously detailed referenced history of what the landscape in Australia was like. Yeah. And his conclusion, I think, is that there is actually more forested land now than there was when Europeans first settled here. Yeah. We've been putting up with this sort of really, it's a case of nonsense, that a lot of Australia has been cleared, whereas in fact much of Australia was clear and was burnt quite frequently during the Indigenous occupation of the land. This leads you into, your sort of starting point is really very doubtful indeed, and until we come to grips with this actual historical details, then I think that you've got to be very careful about what you're doing. On a personal observation, I'm also a bit concerned about those graphs you showed where there was a decline in soil carbon over the last 30 or 40 years. And I just don't believe that's the case in southern Australia anyway. There's been the combination of better fertility, much more crop growth, and you can see the changes in the soil that have gone on over a longer period than the no-till. So that started back in the 60s when the soils were here, for instance, were a very sort of pale orange colour, and they slumped very badly indeed. And this is a factor now that the soil is in much better condition. I don't think there are figures to support this, but the fact is that the soil conditions in Australia have changed enormously, and in southern... Yeah, well, I'm really making a statement that we've got to come to grips with that thing, and I'm curious about how you're going to come to grips with those starting points.
Yeah, well, that's the good questions, and it's something that we've certainly been looking at. The data that I showed there with the decline in soil carbon, I'll start with that one first, is very consistent with data that's been published. There's about I think that's about a 60% reduction in soil carbon over the time period, and consistent with other data that's been modelled across Australia. When you're talking about specific areas, yeah, look, there'll be areas there that wouldn't have declined in soil carbon by that much. This is a national picture, so you won't pull out those specific areas. We could look at the model in particular areas and identify areas that you're talking about, and maybe we've got a better picture in those. But I would be surprised if there wasn't a soil in Australia that hasn't declined in soil carbon since agricultural production. And for your first question about deforestation, yes, look, I totally agree. And our model, the model that we use runs in for 500 years. So we run in back to 1500. And what happens there, if we run from a zero carbon level in 1300, sorry, the carbon will go up to a new equilibrium depending on the vegetation that you have in that system. So if we run that system using sparse grasslands, we will get to a carbon tonnage which is consistent with published data that Ram Delau and Diane Allen have put together for the rangelands. Or if we model down from if we call it all forest and model down for 500 years, we come to the same, clearly the same close value. And you would expect that because the model just churns around with inputs of carbon from that system that's in process to build or deplete carbon stocks within the soil. The difference between starting from a forest soil or starting from zero is the charcoal content, and we estimate the charcoal content from analysis. Now maybe that's wrong, so I would agree that that component of the modelling is likely to be inconsistent, perhaps.
Will make for some very good coffee time conversation with Tony.
Yeah.
There's one more question here from John.
Yes, Bill. Is there an assumption in the modelling that the stock of soil stays the same? Because there's been an enormous amount of erosion in large parts of Australia. Is that accounted for in any way?
No, you're right. Look, the model can't take account of everything. So it's a very rough policy measure, if you like. But I would challenge you to actually provide some data that can support erosion losses or aeolian losses that we could support within the model. I mean, we know there are impacts of changes in soil carbon from one area to the next due to erosion, but we don't have the data to support that, so no, we can't use it. We could guess, but and at the end of the day, we have to validate our decisions to the UNFCCC. And if they say, well, you've got an erosion factor here, where'd that come from? Oh, well, that's out of your back pocket, mate. It wouldn't stand. So if we have some data that actually supports what those losses might be nationally, we can use that.
There's I'm not an expert on this at all, but I know that there was a report by, I think, Stevens, maybe Stevens et al. In South Australia in the 1930s, I think, or 1940s perhaps, which suggested that in the mid-north of South Australia, up to 75% of topsoil had been lost, and this was from observing the soil that had landed in dams. And there's probably other reports like that too. No, but they're only very, very broad figures.
Yeah. Well, you'd have to say though, given our long-term run-ins, even though we don't take account of those erosion losses, where we're running into a carbon stock today, and we've got a measured value, they're pretty close. They're within 10 tonnes. So I'd have to say, no, we deliberately know the erosion losses haven't been taken into account, but for some reason the model seems to work pretty well.
I can add just a little bit to that. Some work, we're actually doing a little bit of work right now using cesium to measure contemporary erosion rates. And one thing, and we're trying to link that back to the carbon modeling efforts, and one thing to say, actually, erosion has been, as you could say, implicitly included in the carbon models because it's been the raw seed component has been calibrated using various sites around the country, and lots of those sites have probably experienced erosion, and erosional losses of carbon is just another loss term, but the only loss term that's in the model is decompositional loss, so it's just buried in that decay constant. So it's a matter of, can we explicitly tease it out and say what's the magnitude, and that's something that we're trying to work on right now, but it is essentially buried within the model if the calibration and validation sites had experienced erosion through their 30, 50, 60-year period that we have those measurements, it will actually be captured in the model. We just don't know what magnitude it's been captured in the model.
Thanks, John. Murray's got a question.
Yeah, there was just a question about the sampling and the modelling, because I really struggle with this too. If you take any two sampling points, and they could be within a year or between years, you can draw a line that can go down, or you can get a line that goes up, or you can get a line that goes across. And in the soil carbon stuff, it's really talking about longer term changes. So I really struggle to see how measurement is going to be much use, in a 5 or a 10-year time frame. You just might get the wrong answer, and really this is where the modelling really is so critical, because the data you showed was an excellent example where you could take, you've got 30 points and you could have anything going in any damn direction you like, and it might be a very accurate measure at that time, but in terms of soil carbon, you can just get the wrong picture. So how do you...
I totally agree.
How do we get this nexus between modelling and measuring wrong?
Well, the problem we have is that in the Carbon Farming Initiative, they are allowing direct measurement. So whilst we might have modelling as a methodology that's, we can't say preferred, but as a methodology, there will also be direct measurement as a methodology. So there'll be people out there that'll be actually taking a soil sample, and that'll be the value that I set as my baseline for whatever period they want to start their carbon trade, their voluntary scheme, and then they'll go and take another sample some point later, where you can see that if you're in a direct measurement program, if you're out there advising, you could scam the system quite easily. You can say, let's take a sample here and say that it was sampled in this manner. Take another sample over there, and you're going to guarantee a change that increases. You could identify those areas in a paddock now. That is the problem I see with direct measurement, apart from all of these issues. And we ought to be, I think we ought to be promoting some scheme that had a modelled outcome, but maybe supported by measurement. And I say that, but I don't know what that would actually look like. But it needs to be robust, And we've got sampling protocols that we use within our own experiments, Do we have confidence in the results that we achieve from those from year to year? Well, we know there's variance. If we can just try and reduce that variance to increase our confidence, know what our level of confidence is, then we're in a better state to say, well, did that really increase or isn't it a change?
I'm sure Lynn will be dealing with some of these issues after the break. And I'd just like to say thank you very much, Bill. And,
Thanks.
thank you very much.